Hello all. In this video, we'll be discussing about lead code problem number 209, that is minimum size subarray sum. So here you are given a target and a sequence of numbers. You have to return the minimum length of a subarray whose sum is greater than or equal to target. If no such subarray exists, then you have to return 0. So for example, in this case, out of the multiple existing solutions of subarrays having a sum of greater than equal to 7, we are having a series of 4 and 3 which is having a minimum length of 2 and the sum is still greater than equal to 7, so that's why the output is 2. So the naive solution for this can be, we'll be taking two pointers I and j and we'll be looking for every combination of numbers and we'll be calculating the in between sums of them. If the sum is greater than equal to 7, then we'll be updating the length of the target to minimum. So here, as you can see, for 0 to 0, 0 to 1, 0 to 2. So these are the numbers that we are considering. And here, since sum is greater than equal to 7 in these cases, however, the minimum length is 4. So that's why for these specific cases, the length will be untouched, minimum to 4. Further, while we'll be looking for all possible combinations, at the end we'll encounter a sequence of 4 and 3 where sum will be greater than equal to target and length will be 2. Since 2 is less than 4, so that's why we'll be updating that further to 2, and this is how we'll be getting the answer at the end. Now, when talking about the time complexity for this solution, you can say that one pass is for I, one pass is for j, and further we have calculated the sum between, and in worst case, it will also go for n. So that's why the time complexity for this will come out to be O of n cube. And space complexity will be O of 1 since we have only used one sum and maybe one length variable. This is not the efficient solution, so let's have a look on the efficient solution. We'll be solving this question via sliding window. So here what we'll be doing, again we'll be initializing two variables, sum and length will be initialized to int max, that is maximum value, since we have to deal with minimum value of length later. So we'll be initializing two variables I and j, and we'll be maintaining a window which will be having a target length of 7. And once we will be achieving that 7, we'll try to reduce the window size such that if there exists any shorter length which still completes the constraint of target sum 7 or greater and having a length minimum. So let's start. So first of all, it will be going for 2. So that's why the only considered element is 2. So that's why sum will be updated to 2. Then we'll be going for extension of the window, that is 3. 2 plus 3 will give me 5. Again, it is still not equal to the target, so we'll be keep on extending it. So as of now, 1, so 5 plus 1 is 6, still it is less, so that's why we'll be extending the window size to further next element. Now here the sum is greater than equal to 7, so that's why we have achieved a window size of 4 here, right? So 2 1 2 1 3 4, so there are 4 elements, so we can say that we'll be updating the length here to 4. Now, since we have achieved the window size of means a target we have achieved, target sum we have achieved. So what we'll be doing, we'll try to decrease the window size now. So here I'll be trying to reduce it via moving this pointer, that is left one. So it will be at 3. Now, since it is out of the window, we'll be subtracting its sum from the main target sum. So here we are having a 6. So now the target is not equal to 7. So again, we'll try to extend the window size. So now by freezing this pointer here, we'll be trying to extend the window size and moving this pointer. Now 6 plus 4 will give me 10. So now again we have achieved a sum of 10. We'll be looking for length. Now again it is 4. So since 4 and 4 minimum is 4 only, so it will not be further updated. Now since we have achieved the target sum, we'll try to decrease the window size. So basically the pointer will move here and we'll be having a sum of 4, 5, 6 and 7. Means basically we have to do 10 minus 3 which will give me 7. Still the target is met, so I'll be looking for the length. Yes, j minus I plus 1, the length is still 3. So since 3 is minimum, so I'll be updating the length to 3. Further, I'll be decreasing the window size to this 4, 5, 6. Means 7 minus 1, the element that is out, right? So 7 minus will give me 6. Now since it is not the meeting the target, so that's why we'll try to extend the window again. So now we'll be moving this pointer further. So here we'll be having 6 plus 3 will give me 9. So it is again acceptable. Now we'll be looking for the length. It is already 3. 3 elements are considered, so that's why it's okay. Now we'll try to decrease the window size by moving this pointer. Now we'll be having this 9 minus 2 will give me 7. So still the window size, the target is achieved 7, but the window size is reduced to 2 elements only. Since out of 3 and 2, 2 is minimum. So that's why here it will be updated to 2. And in the next case, the left pointer will further move and we'll be having a window size of only 3. 7 minus 4 will give me 3. And since there is no further place to move ahead, so the algorithm will terminate and we'll be having a length of 2. For this specific case, we can see that we have used only one pass. So that's why we can say that time complexity for this solution is O of n. Whereas space complexity, we have used only two variables. So that's why the space complexity will be O of 1. So that's all. Let's see the code now. The code is as simple as the concept. So here we have declared a n, answer to int max, left and sum. We'll be using one pass and we'll be keeping updating the sum. While sum is greater than equal to target, we'll be comparing it that if we have achieved the target window size and constraint. So here sum will be greater than equal to 7, then we'll be updating our answer to the minimum. Previous answer plus length of the window. So it will be updated further and then we'll be excluding the leftmost element from the window such that we are reducing our window size. So this will keep on going until unless we have traversed all the elements in one pass. At the end, what we'll be seeing is if the answer that we have declared at the start, if it is not equal to the initial value, then certainly we have obtained some answer and we'll be returning that. Otherwise, we'll be returning a 0 such that we have not attained any solution for the problem. So that's all from my side. Thank you for watching. Have a nice day.